Hola, buenos días a todos.
Hello, good morning, everyone. Welcome to this workshop formed by the Inter-American Coordinating Group in Plant Protection, GICSV, with the support of ICA. Today, the workshop regards biocontrol and climate forecast focused on locusts. I would like to introduce the people that will be heading this event, Ms. Stephanie Bloom. She's Executive Director of ANEPO. And currently she is the coordinator of GICSV. And then Ana Marisa Cordero, the manager of the Animal Health and Food Safety Program at ICA, for their opening remarks. Go ahead, Stephanie.
Good morning, everybody, and greetings from the North American Plant Protection Organization. Our secretariat is here in Raleigh, North Carolina. And as Lourdes mentioned just a moment ago, I have had the privilege of coordinating the activities of the 5 regional plant protection organizations that form the GICSV during the last year and a half. So in that role, I would like to give everyone a welcome to this wonderful event that was organized by one of our most active working groups in the GICSV space, and this is our working group on locusts. I would like to thank ICA for facilitating the webinar, and I would like to welcome and thank our speakers in advance of their presentations for their willingness to share their knowledge with us. So I hope we have a wonderful event today, and thank you for joining us. Ana Marisa, over to you.
Hola, hola. Buenos días.
Hello, everyone. Good morning. Thank you, Stephanie. Greetings from Costa Rica for you. And thank you, Lourdes, for the introduction. Greetings to all the people that have joined us today at such an important event for the Animal Health and Food Safety Program at ICA. I would also like to express my greetings and a special appreciation to our speakers and GICSV. This is an initiative that, for us, is extremely important to identify areas of action and joint work together with the regional plant protection organizations. And especially, I would like to thank each and every person that is with us today for their interest and commitment to the subject matter. From the Animal Health and Food Safety Program, we very much foster work that helps to develop and work on capacity building to help us adopt best practices and cover issues and opportunities from the capacity building stance at a national and regional level as a way to prevent and prepare and better manage an effective response in the event of emerging sanitary or phytosanitary issues or outbreaks. And today we are here to discuss matters that one way or another will allow us to learn about new technologies and knowledge management. This, one way or another, will help us support our official services so that they are more aware of how to incorporate these new technologies and how, through the space we have today, we can also share good practices, share experiences, and learn one from another. So I urge you to really tap this event, get the best out of it, and share with your peers and pose questions to our speakers in order to continue strengthening our capacities. So once again, on behalf of the Animal Health Program at ICA, a big hug, and I wish you all the best. Thank you. Thank you, Ana Marisa. Thank you, Stephanie, for your opening remarks. Now, allow me to introduce Engineer Hector Medina. Hector, aside from being a specialist in locust at the SENASA in Argentina, the NPPO in Argentina, he coordinates the GICSV working group on pest orthoptera. So he will refer to the objectives, and he will be our next speaker, therefore. Thank you, Lourdes. Well, welcome, everyone. I would also like to thank the organizing team of this seminar. I would like to thank NAPO, our GICSV group, and particularly our speakers today. As Lourdes mentioned, as well as Stephanie, there is a specific group that works throughout the context in the area of grasshoppers and locusts. And the objective of our group is to exchange information, share progress in the management of these pests, but also to understand the needs that we may see in the different countries and regions of our continent. So in this sense, when we talk about locust control and grasshopper control also, we see there's a big weakness throughout the entire continent to have the necessary tools. We believe that biological control is necessary as part of management, and it is necessary for the countries to incorporate technologies in the short term. Now, something similar we have seen in everything related to the early warning systems, and we believe that to improve the early warning system, the weather forecasts and things like this are of vital importance. So, down the lines of work of this group, these are two very important and relevant elements, and that is why we have called upon these experts to tell us about the work they are doing elsewhere in the world, and thus share it with all the countries and regions of our continent, as well as with other colleagues from other parts of the world that are also participating in this seminar. Before I offer the floor to the first speaker, as Ana Marisa was saying, you can use Facebook or YouTube to post questions, and we can pass these on to the speakers once they finish their different presentations. To not take further time and move into the presentations now, our first speaker is Jean Dutton. He has a PhD from the weather department at Penn State, meteorology department, and he will talk about long-range forecasting to improve locust early warning systems. Jean, the floor is yours.
Great, thank you very much. Muchas gracias. May I just ask, is my screen visible? Great. So, as was mentioned, today I'm going to talk about long-range forecasting to improve locust early warning systems. And so to introduce the company, we are a private company called Prescient Weather. And we really offer two primary products. One is called Crop Profit. And so Crop Profit integrates weather and climate information to forecast the yield and production of different crops, but are primarily corn and soybeans. And then our other product is the World Climate Service, which is really a tool set to enable better long-range forecasting. So our company is focused on using climate information to create value-added decision systems for our customers. When thinking about the World Climate Service, we like to think in terms of what is the time scale of the forecast that we are providing. So weather forecasts can be made from minutes to days in advance. And then longer range forecasts, which are called subseasonal or seasonal forecasts, can be weeks or months in advance. And then because of climate change, we also talk about climate projections, which are what will happen years or decades from now. So for the World Climate Service, we focus primarily on the seasonal and the subseasonal time frame. And what's important about this is that a weather forecast is really dependent on the initial conditions. And as the forecast lead goes out, so as you go many days into the future, the importance of those initial conditions becomes less important because of the non-linearity in the atmosphere. And as you go further and further out, the boundary conditions start to become more important. And so just to make sure that we understand what we're talking about, a deterministic forecast, which is dependent on the initial conditions, is when we're predicting a specific variable for a specific time. And so an example would be that the temperature on Monday will be 20 degrees Celsius. A probabilistic forecast is predicting the likelihood of an event occurring. So it's predicting how certain we are of something. So for example, a probabilistic forecast is like saying that the average temperatures have a 60% chance of being above normal next week. And so the difference again between these two is that a weather forecast is really dependent on what is happening right now when we start to run the model forecast. Whereas a climate forecast or a longer term forecast is dependent on what affects what is happening right now, which is the boundary conditions. So the example that many, many people know is La Nina, which is sea surface temperatures in the tropical Pacific. So this blue here is colder than normal sea surface temperatures and is the signature of a classic La Nina signal, which is what's occurring right now. There are other factors that are important, like soil moistures, and then other dynamics within the climate system create this long-term predictability. And so with the World Climate Service, we're focused more on this longer-term prediction information. But I would say we can't avoid the weather forecast information, but we try to focus on the longer-term predictions. So I would like to highlight that the United Nations University Institute for Environment and Human Security highlighted the Middle Eastern and African locust outbreak of 2021 as one of the 20 most important notable natural disasters of 2020 and 2021. And what is interesting about this locust outbreak in this region is that it was largely driven by weather. Certainly other factors were important, but weather was a major factor that caused this outbreak to happen. And in particular, as this diagram shows, there were several cyclones that hit the Arabian Peninsula, which created a lot of moisture in the soil and allowed the locust populations to grow rapidly. And then from there, they spread over time to the African continent and created just a lot of damage and a big problem. And so, obviously I'm talking here to a group that is particularly worried about locusts. So you don't need to know how important it is, but it is recognized on the global scale that locusts can be a major problem. And the key for me is that weather conditions are a critical environmental factor that enable locust swarms to grow out of control. And so that is why the UN, the United Nations Food and Agriculture Organization, so the UNFAO, Desert Locust Information Service, actually uses the World Climate Service as their long-term precipitation, temperature, and wind speed forecast service. If you go to their website, as I show here on this page, there is a link to a report, which I've got circled down in the lower left. If you click on that link, the report opens, and what you see, for example, in that report is forecasts of precipitation. And so the data shown in this report comes directly from the World Climate Service. The text in this image is a little bit hard to read, but so I expanded it for us. And so, for example, it says that the seasonal precipitation predictions are provided by the World Climate Service. So we're very proud and honored to be able to provide this information to the UN FAO in their service. And if you go further in to understand their system, it turns out the Desert Locust Information System has an internal geographic information system that we provide a service to allow them to integrate the forecast information. And in addition to that, we prepare some specialized products for them, where they have given us the regions of particular concern for them. And we post-process some of the forecast model data, and we provide precipitation forecasts for months into the future. So remember this image, because we will talk about it more in a little bit. So in thinking about an early warning system for locusts, or really any early warning system that relates to climate, we can think about the different forecast types that are available. So there is seasonal to monthly forecast. There's sub-seasonal or weekly forecast. And then there's daily, and I apologize, this should not say weekly. That is an error. But there are daily forecasts that are weather forecasts information. And so in thinking about how to use an early warning system, the idea is that the seasonal to monthly forecasts highlight potential risks. So for example, we know that during a La Nina, certain climatic factors occur all over the world. And we know during an El Nino, certain climate factors or climate events can occur. So if you're aware, right now in Eastern Australia, there is very heavy precipitation that has happened over the past 2 months. And that is driven by the Indian Ocean dipole, which is similar to La Nina, but occurs in the Indian Ocean. So that's a great example where if we know that an Indian Ocean dipole, in fact, in this case, if we know that a negative Indian Ocean dipole is forecast, we can expect certain conditions to happen in Australia. So knowing that we've highlighted the potential risks, we can then start to look at the weekly forecast, and based on those weekly forecasts, we might raise the awareness of a particular risk. So relative to locust outbreaks, we might say that a particular climate event suggests higher than normal precipitation for a region that is at risk to locusts. We then might focus on the weekly forecast, say 3, 4, or 5 weeks in advance, to try to get information that would highlight whether those precipitation events are going to start or not. And we might start to align resources to try to control the situation. And then as we get into, say, 14 days before the forecast event, we start looking at weather forecast information, and we can actually start acting on the information and deploying the resources to try to prevent the dangerous situation from occurring. So there's multiple sources for long-range forecast information. When you look at long-range forecasts, most people are focused on the dynamical models. So these are mathematical representations of the atmosphere that we use to model the future. And the widely known models, for example, are the European model. So the ECMWF is the European model. NOAA has the climate forecast system for seasonal information. and then the global ensemble forecast system for weekly forecasts. And then a European program called Copernicus makes a wide range of seasonal forecast models available. So dynamical models are pretty widely available. There's also statistical analysis, which is, in fact, you can build complex statistical models to forecast what will happen based on history. And a common source of information there is called ERA5, which is it's the ECMWF historical data. And then there are analog tools as well. And the analog tools are generally driven by climate indices. So climate indexes like the El Nino La Nina index or the Indian Ocean dipole. And when we're looking at analog tools, we're finding times in the past that were similar to today. And the idea is what happened in the past gives us information about what may happen in the future. And so in our own experience, in Prescient Weather's experience, the combination of these three tools are critical to create long-range forecast skill when we're talking in particular about monthly and seasonal forecasts. So just to provide an example of an analog forecast, on the left-hand side, I've created a seasonal or a monthly analog in this case, where I've looked at the impact of La Nina during September, October, November on precipitation during September, October, and November. And so we're finding months in the past when there was a La Nina during September, October, November. And what the map shows then is what happens during September, October, November. And we see across much of Central America, there are higher probabilities or increased chances of above normal precipitation. On the right-hand side is a subseasonal analog. So there is a phenomena in the tropical Pacific Ocean called the Madden-Julian oscillation. And it is basically heavy precipitation moves back and forth across the Pacific Ocean. And it can change the circulation patterns. And so what we're looking at is the impact of what is called a strong phase 7 Madden-Julian oscillation occurring on October 31st. And what the impact is 21 days later. So 3 weeks after a Madden-Julian phase 7 event, it tends to be wet in northern South America, but dry in most of Central America. So the idea is we can monitor the climate and we can use analogs to try to get information about what might happen in the future. So this is one source of long-range forecasts. So I mentioned that dynamical models are pretty widely used. What is generally not widely used from the models is probabilistic information. So what I've shown here is this is a 2-week forecast from the European model showing higher chances of drier conditions. So this is increased probabilities of below normal precipitation across much of South America. And what we can do as well is we can pick a particular point. So I've chosen a point where the X is. And we see, for example, in this forecast that the probability shows 75% chance of below normal conditions. So the idea is that the initial conditions allow us to make a deterministic forecast, but the boundary conditions and the uncertainty that starts happening with weather forecasts and long-range forecasts means we have to consider the probabilities of different events occurring. And so in this case, we are looking at 75% chance of below normal conditions. But that doesn't mean that week can't have heavy precipitation. In this case, the models are suggesting, though, that there's only a 5% chance of precipitation being above normal. So this probabilistic view allows us to interpret the risk of a particular outcome or a particular situation. So how do we do this? How do we create these probabilistic forecasts? If we consider, for example, a temperature distribution, temperatures averaged over a week or averaged over a month for a particular time period tend to be normally distributed in the statistical sense. And what we do in the long range forecast is we segment this distribution into equally probable events. And those equally probable events in this case would be below normal temperatures, and above normal temperatures. So if we had no information about the future for a given location, we would forecast 33% chance of below normal, 33% chance of normal, and 33% chance of above normal. So each is equally likely to occur. But the dynamical models give us information about the future, and we try to post-process those models to create a forecast like this. So what we see underneath is the original distribution, but the models might suggest it's going to be colder than normal. And in fact, they might suggest it's going to be colder than normal with a 50% chance. And so the distribution of the outcome has shifted. And what that means then is there's only a 50% chance for normal or above normal conditions to happen. And as we saw in that precipitation example, it means something like, let's say 40% chance of normal, and then only 10% chance of above normal conditions. So the idea is that we're using the model forecast information to try to understand how the distribution is going to change in the future. And so in this case, if this were a 3-week forecast and we issued a 50% chance of below normal temperatures, and then 3 weeks later, it ends up being colder than normal for that location, the forecast was said to be correct. And what that means is the most likely probability in this case was correct. And if it ends up being warmer than normal or normal, the forecast is said to be incorrect. And so how do we achieve this? We achieve this through a process called calibration. So it turns out when the modeling centers, like the United States NOAA organization or the National Weather Service, releases these long-range forecast models, they also release 20 years of reforecast data. And so that 20 years of data is literally, it's the same model, but they forecast earlier dates up, and it's up to 20 years of earlier dates. And so we can use that reforecast data to understand how the model performs. We can correct for errors that we see occurring in prior forecasts. But more important, we can adjust the uncertainty of the forecast. And so we can adjust the uncertainty of the forecast such that when we say that a forecast event is going to occur with, say, 50% probability, that it then occurs 50% of the time. So when that occurs, the forecast is said to be reliable. So a reliable forecast is that the event occurs with the probability that the forecast says it's going to occur. So we can take an example forecast, for example. So we've already looked at one, but here is a 3-week forecast for temperatures in Europe. And we see, for example, where it's forecasting greater chances of below normal temperatures, say in Italy. And we can look at what's called a reliability diagram. And so on the x-axis, we see the forecast probability. So for example, the 70% here, this would be let's say a 70% chance of above normal temperatures. And when the model is uncalibrated, so when we just use the raw model data, we see that during June, July, and August, this 70% forecast occurred roughly, call it 42% of the time. After we calibrate the forecast, however, we see that the 70% probability occurred slightly more, so let's call it 72%. But what we want is the calibrated forecast to fall along this black line. So what we want is we want to be able to say that the forecasted event, like above normal temperatures, is 70% chance, and we want it to occur 70% of the time. And so what we see is the process of calibration tends to improve the forecast. Calibration is what makes the long-range forecast useful. And so in this case, just using the model data without any value-added information, we see that the forecasts are overconfident. that the predicted probabilities were too high. And so calibration is a process to try to create reliable forecasts from the model data. And so I just want to highlight here that we have a simple example in which we might issue a forecast with above normal temperatures at 60%. And then the temperatures ended up above. So we end up with that forecast was correct. And likewise, we had a dominant probability, or the maximum probability of above normal was 50%. But the observations came in at normal, so that forecast was incorrect. So we have 4 example forecasts. We have 4 outcomes or 4 observed events. And so in this case, the fraction correct of this simple example was 50%. So this is how we evaluate these probability forecasts. And it's called the tercile fraction correct. So the reason I'm bringing this up is one of the really interesting things about calibration, looking at this solid line, is we have across the bottom the forecast of the probability of at least a certain amount. So probability is greater than a certain amount. And then we have the tercile fraction correct. So the y-axis here is how skillful is the forecast. And then the x-axis is what was the probability of the forecast. And so this is particularly true for the weekly forecasts. So week 3 and week 4 forecasts, is that your confidence in the forecast is directly related to the probability of the forecast. And we see the difference between the green line and the black line is the value that calibration adds to the forecast. The penalty you pay for calibration, though, is that high probability forecasts occur exponentially less often. So, for example, in this case of December, January, and February U.S. forecasts, United States forecasts, 70% forecasts happen only 2 or 3% of the time. So they happen rarely, but when they do happen, the forecast is highly skillful. So most people think that forecasts beyond 14 days have no skill. It turns out that's incorrect. If you can calibrate a forecast, average over time, and then find a period where there's a high probability forecast, you'll find that there is in fact skill in these long range forecasts. And so I want to show an extreme example here in which, again, we're looking at the European model, June, July, August, and then this is precipitation. So we're looking at summertime precipitation forecasts. And I just want to highlight that the uncalibrated forecast has essentially no skill. Which is to say that it's almost flat across the graph here. But when we calibrate it, then we see that the forecasts become reliable. The forecasts fall along this black line. So calibration can add benefits to the long range forecast information. So let's turn to the area of the world that we are concerned about. So I've had a couple of conversations with Mario Put, and he gave me shape files of the regions for Southern Hemisphere locust monitoring. Those are the regions in red here. And so we can also produce a different type of product. And in fact, we produced it for several months. And so the idea is we can look at months ahead for different models targeting these specific regions. So this is this was the precipitation forecast for Northeast Mexico. And then just like this is the forecast precipitation for Paraguay. So I want to zoom in on one of these and let's just look at this for a second. So looking at the forecast for Mexico, what we see is different models, and these are basically produced by different countries. And we see then different months, so October and November and December. And then what's shown then is the percent of normal precipitation. And then what's shown in green is the normal precipitation. So the idea is that that region in Mexico normally receives 72 millimeters of precipitation. And the forecast for October, issued in September, showed basically normal precipitation can be expected. And so the idea is that this is a different type of probability forecast. And if the models are very, very different, we don't have a lot of confidence in the forecast. If, however, the models are all consistent, so for example, this January of 2023 forecast, we see that all of the models are below normal. So in September, the idea was we could expect January forecasts, or we can expect January precipitation to be below normal. And so this is a type of forecast where we're trying to sort of specialize the information to the particular application. And so to come back to the original concept of using long-range forecasts as an early warning system, and knowing that the risk of locust outbreaks is particularly at risk to precipitation, we can, for example, consider that we might look at a seasonal to monthly forecast. So in this case, monthly forecast for specific regions, and use this as a guide towards whether there's a potential risk in the future. So if many of the models were above normal, we might start to become concerned about what it means for locust. And then we might, as October came into view, we might start looking at the subseasonal forecast, and in particular, whether the probabilities are higher than normal for precipitation, 3 or 4 weeks in advance. And if they remain high, we would then look towards the precipitation forecast in terms of the weather forecast, the daily deterministic forecast, to try to decide if we need to take action to mitigate the impact that precipitation will have on the locust population. The same is true in the reverse. The monthly forecast might show below normal precipitation, suggesting there's no need for concern. And then we might look at the weekly or the weekly subseasonal forecast, and it might show, as this one does, that the probability of below normal precipitation is very high. And then we might look at the weather forecast, and for this particular region in Paraguay, see that the forecast remains very, very dry. And so we don't have to worry about potential outbreaks due to precipitation. So the idea then, or to summarize, is that for long-range forecasting, probabilistic forecasts are really necessary for lead times greater than the traditional 7 to 14-day forecast information. And what the modern science suggests for long-range forecasts is that it's important to compare different sources of information. That might be different forecast models in the graphic that we were just looking at. It might be comparing the dynamical forecast with the analog forecast information. And our forecasters know in producing a seasonal forecast that the analog information does add value to the overall forecast. And really the most important thing is to use the information available to maximize the early warning potential. And what I've tried to highlight then is that there's a waterfall of opportunity where you start worrying about risks in the seasonal to monthly time frame, so you can think about it months in advance. And then the subseasonal or weekly forecast help to raise awareness that there's a potential event coming. And then the idea would be that the weather forecasts are when you really need to start thinking about taking action. And that's all I have. Thank you very much.
Muchas gracias, Jan, por esta.
Thank you very much, Jan, for this wonderful presentation. Now we're going to move to the question session from our public. We have some of them. For instance, if it's possible that the information on forecasts can be seen or can be given by the company via web service.
That is a great question. So we currently provide our forecast information via a web-based portal. So it's you log in and you hit buttons to get different pieces of information. We also provide the information via data files that can be downloaded from our servers. And then it turns out we do provide the UN FAO a web mapping service to integrate directly into their API, to integrate directly into their geographic information system. That is not an official product, but they've been using it now for 2 years and we haven't had any problems. So I'm sure that we could consider providing data via a web service as well.
Ok, muchas gracias. La otra pregunta.
Thank you. The other question is if work had been done with the FAO, has there been any requirement for training to the staff using this information service?
That is a great question. It turns out that our user at the UNFAO has been a user for almost, I think it's been over 10 years. And I'll just say through his own experience in using our product, he has learned like when to rely on the information and maybe when not to. So we actually have not provided extensive training to the UN FAO staff, but in part it's because our user is very knowledgeable already in how to use this type of information. Certainly, there's no reason why we wouldn't consider providing training, however. It does tend to be highly technical information, and training certainly could be a possibility.
Ok, gracias.
Thank you. There's another question here. We have been talking about El Niño or La Niña in the continent. However, there are differences that are highlighted regarding the effects of El Niño or La Niña in between Central America and South America. There have been a bit of confusion. I don't know if you could talk a little bit, what effects has El Niño in Central America, in South America, and La Niña in Central America and South America? Because the confusion can be that we think that the effect could be the same in Central America and South America.
Sure. That is a great question. Let me go back to my analog. So first off, it's important to understand that not all La Niñas and not El Niños are the same. So for example, there is an El Modiqui El Niño, where there's a very particular sea surface temperature pattern, and that tends to have slightly different impacts really in many places around the world. And so one of the things that is important, and I'll just say within our tool, for example, once you've selected this La Niña in September, October, and November, the years that get selected show up in a little bar. And you might, and let's say 2017 is one of the years, but you know that 2017 was a year that is dramatically different La Niña than other years. So you can remove that from the data set, reanalyze it, and you get a different impact map. And I will say, I actually, the beauty of having the World Climate Service is I don't have to memorize things like what La Niña means all over the world. And what I wish is that I had World Climate Service running right now, and we could go look at what La Niña and El Niño means for Central America versus South America. So again, I will highlight here that for this September, October, November example, we see that we see the years that are selected as being a La Niña during September, October, November. And we see that, again, it's increased chances of wetter conditions. So what's interesting, for example, so this area is, this is 75 to 85% chance of wetter conditions in Southern Central America. That still means there's a 25% chance of normal or below normal precipitation during a La Niña event, right? So it means that the distribution is shifted towards wetter than normal, but it doesn't mean drier than normal can't happen. And then if we went further south in this map, we would see that it was we can see the start of drier than normal. So if we go further south, we would see drier than normal. So I apologize. I can't quite comment on specifically what different El Nino versus La Nina during different times of the year mean for different parts of the two continents.
Perfecto. Muy bien. Recibimos aquí una.
We receive a question from Facebook, and they're asking, what space scale do you generate this forecast?
So ask that again.
Sí. ¿Cuál es la escala?
What is the scale, the space scale?
The spatial scale. So we analyze all of our data on a 1 degree by 1 degree grid. And I will just explain that the reason that is because earlier I mentioned the European model. So as a private company, we have to buy the data from the European Center. And so we basically pay by gigabyte. And so as a result of that, we access 1 degree by 1 degree data because higher resolution data would be very, very expensive.
Okay. Okay, hay otra pregunta.
There's another question. I don't know if you can help with there, because they're mixing the question, the issues about locusts and the environment. If you have knowledge, if there is a drought period and how long this drought will last, could it have an effect on locust outbreak? This is a mixture of weather knowledge and locust expertise. I don't know if you could provide some information.
Sure. I guess I will do my best from supporting the UNFAO and, to be honest, getting ready for this webinar. You know, what I've learned is that there is a threshold of precipitation above which locust populations can grow exponentially. And so the idea is that the soil moisture supports the larvae and basically the birth of the locust. So it should be that a drought should suppress locust populations. And I would imagine that if the drought is severe enough and long enough, it actually kills the locust, or let's say the locust can't survive in the soil, and it actually greatly reduces the populations. And it would probably therefore take a sustained period of precipitation for the locust population to become dangerous again. So on the core, it should be that an extended drought significantly inhibits locust populations from growing. Did I get that right, Hector?
Did I answer properly, Hector?
Claro, muchas gracias. Ya casi para finalizar con las preguntas.
Well, almost there to finish the question. We have another question. From your vision, how do you consider, why don't you consider the forecast, the weather forecast, as a mandatory session for pest management?
I do. I just haven't been able to get people to listen, maybe. How about this? I would love if it were. And I can certainly try to support the effort.
Mm-hmm. Okay, creo que ya no tendríamos.
I think we don't have any other questions. Thank you very much.
Muchas gracias.
And maybe we have your email address, so there must be probably more questions for those listening to us so that they can send their questions to you directly.
Please.
Muchísimas gracias.
Thank you very much.
My pleasure.
Now, following our agenda, next, we have the presentation on biological control with metarhizium, acridium, and ecological alternative for Autoctonium pest management. Our speaker is Bastien Claire. I hope I pronounce it properly. He is a technical, he works for Elephant Bird, sales manager for Europe and Latam. He's a specialist in pest management and crop and disease management. It is important for him to fight for a preferable agriculture for farmers through different solutions from nutrition to integrated management of pests and diseases. Thank you very much, Bastien. We'll leave you now with the presentation. Thank you very much, Mario. Good morning, everybody. I'm going to share my presentation.
Vale, pues primero encantado
First, it is a pleasure to be participating in this webinar. I'm with Mr. Lionel and other colleagues which also work in elephant bird, in biocontrol, specifically for locust. Before getting into the topic or the products we have to the recommended control to manage locust, I would like to mention, introduce a little bit my company, Elephant Bird, which specialized in microorganisms. Previously, it was an association in Africa that was looking for biosolutions for agriculture. Since there were several discoveries on microorganisms, they decided to create the company in 2012, 10 years ago, so that we can trade all these biosolutions we found. We are expert in biostimulants and biocontrol with microorganisms, among methartesium acridium, which is for locusts, and we also have our products which we also manufacture and we sell as biostimulants to control other pests and diseases. You can see here several places where we manufacture our products. In Morocco, we have a plant totally exclusive for production of methartesium acridium, which is the fungi we use to fight ecologically, biologically, the locust. First, I know you are experts in locust. For those who are not, just a brief summary. The locust is a type of grasshopper which is with specific characteristic, and in terms of when they have certain climatic conditions which allow the population of locusts to grow and gather in vegetation island, if we could say so, this grasshopper changed completely physically and in its behavior, and it moved from solitary phase, which behave similar to any grasshopper, to the gregarious. And that's when he creates large swarm, which are a threat for food safety and for crops in general, for us as well. Thus, the locust, and the objective is to avoid that goes to this gregarious phase. Mainly, the life cycle of the locust, the eggs are on the floor, on the soil, and moist soil, mud, and that's when there are moist condition or heat conditions, and the eggs outbreak, and that's where they start their life cycle, which could be very fast in terms of the climatic characteristic. Every time we see that there are more generations per year, this year could be 2, sometimes we see 3 generations, which is a serious issue. And we have to try to look for tools to avoid these generations grow too fast so that they can sexually mature and to reproduce in high amounts. What are the challenges? Very important. Locust is very risk for the economic stability, for food security, and livestock in general. What happened? Today we have a lot of preventive control. We can see that during many years in South America, there were issues with locust, and there is a preventive control. That image, I took it from a scientific article. Maybe some of you have participated in this article. It's very interesting, and we can see the preventive control has been useful for many years, but now with the hypothesis that there is more generations per year, preventive control is not working. We have to look for new tools to fight against this pest. That's where we come with the new products we have been using for years in Africa and in some countries in India, Pakistan, and others. This product is Novacrit, which is made of exclusively by Methacerium acridine, which is a specific fungi. Just to give you a brief history of the product, it was an association which Lubilosa, which were using this fungi to fight with the locusts. And this fungi, it was selective and it was only attacking locust. That's when they start growing and they try to create an industrial product, and the challenge was a little bit complicated, and that's where they met elephant bird. At the industrial level, it is a fungi that is hard to reproduce, so there's have to have certain techniques, a lot of tools, very expensive ones. And on top of that, it is a product that we have to produce and not produce at the same time, which is an industrial challenge. And Elephant Bear at that time, because it's a company which is well established in Africa, they tried to invest and have a product, an ecological product against locust, efficient against locusts. They invested a lot and they developed this product. They did not select the same strains as those selected by Lubilosa back then. But over the years, with the experience and all the practices, they selected a different strain of this fungi, which was more efficient, that is, and easier to reproduce. In a few words, the product is completely harmless to the environment, both for human beings as well as insects, flora, fauna. And it is a very good alternative instead of chemical pesticides that we normally use now. Why? Well, because it is has a longer persistence and therefore more effective. Or it is a biological product, so 100% Methacerium acridine. And why did we select this as a concrete fungus? Well, this fungus is found in any type of soil.
basically throughout the entire planet. But this specific strain comes from soils from tropical and subtropical areas instead. So it only selects the locust to grow and is a fungus that adapts very well to these areas. So it is much easier for the fungus to prevail in the environment and infect as many locusts as possible.
Un hongo que es capaz de estar
So this is a fungus that is active many hours a day. So how does it work? Well, we apply the treatment with the product, either aerial or with any type of spray or sprayer. It's basically the same, but basically we will launch a lot of spores into the air that will stick or adhere to the locust cuticle. They will germinate on the cuticle, and then thanks to two things, to an enzymatic action and osmotic pressure, the fungus will penetrate the locust. It will get into the hemolymph, and the hemolymph, which is basically the blood in humans, will serve as a nutrient source for the fungus. The fungus will begin to develop and consume all the nutrients that the locust should have consumed, and therefore it will weaken the locust significantly. And we have seen that between 2 and 4 days later, the locust stops eating. So from the time we do the treatment, about 4 days later, all affected locusts will stop eating. And that is the most important part for us, because once it stops eating, it is no longer a threat for crops and for food security. When it stops eating, it will survive a few more days because it's a pretty strong insect, but will end up dying around 10, 15, 20 days. It will just die from starvation. And then the dead bodies, where the Methoricium is still located, will be a source of contamination to the other locusts. And that is what we are interested in. And as compared to a chemical pesticide, this will be much more productive. We will infect more locusts than the ones we initially touched with the product. As to a spray application, well, it could be water-based, with the normal water spraying systems, with a backpack, or with pulled by a trailer. And we also have the option to do this with the ULV method, ultra low volume spraying. So with a bit of oil, we can spray per hectare with our product from 1 to 4 liters of liquid per hectare. Just imagine, and that allows us to reach more remote areas, areas of greater that are harder to access, and we will treat more hectares with less product. So the product, as I said, is very concentrated. The concentration of Methoricium acridum in fungus is very important. So we have some spray doses that are rates that are very low, 50 grams per hectare. We could increase a bit in the event of significant vegetation, but it's usually 50 grams per hectare, and it is very effective. By spraying it with water, we will spray between 50 and 300 liters per hectare. If we want to spray with less water, we will have to add a surfactant so that the product adheres on the locust. And then, as to the ULV method, we will treat with 1 to 4 liters per hectare 1 liter hectare to 2 liters round, for example. So our challenge now is, excuse me, now what did I do? Oh, our challenge now is conservation and product viability. For many years, we have been working on this, and now, with the technique we have in the manufacturing process, we have come up with a very stable product that can be stored well, and its life storage is several years now. We have a storage area that can store 3 tons of the product. We're in Morocco, where we manufacture it, and we store part of the customer requests, so to avoid the product from aging. Now, as to spraying, as many other products, it needs to be sprayed without much wind. The less wind, the better. It is better to spray in the morning or in the afternoon when the temperatures are not extreme. Metarhizium acridum is active very well between 20 and 35 degrees, basically the same time when the locust larvae are in motion. And with this, we can directly contact the larvae, and the efficacy could be very broad in areas with limited vegetation, and in drier areas, well, the product will remain for less time, and in areas with greater vegetation, well, we can the duration is 4 to 6 weeks. Even with bacteria and microbes in the area, well, everything will, our strain will disappear completely. We have a lot of assays throughout Africa or trials in different parts of Africa. Here you can see a list of the countries, and we do trials also with several locust species. We have applied the product in many locust species, and it has always been successful. Here we can see, as I was saying before, that after about 3 days they stop eating, and mortality begins as of day 10 approximately, with a peak at day 16. It does not have secondary effects on birds or similar elements. These are results of several field trials with locust pests. This basically shows Kazakhstan with the microdori locust. 50 grams per hectare were applied of the product, and we can see that death as of day 3 was very limited, but as of day 19, almost 100%, 96% specifically of the locust had died out. How did we go about these trials? We sprayed the product in the areas where the locust was breeding and where there were swarms, and then we went to these areas. We collected a lot of locusts that we later took to the lab to see how many were dying and how many were surviving. So that is how we saw it. And we did the same here in Niger, but with a different type of locust, comparing spraying Novacritic with malathion, a product that is used extensively in Africa to fight against locust. Very inexpensive, by the way, very readily available, but very toxic. And its efficacy against locust, they die the minute they enter in contact with the product, but then all the part of the population that was not directly touched by the product can start all over again with their breeding process. Very quickly, they can form swarms again and cause problems. So we saw that as 3 weeks after the treatment, the parts that had been treated with malathion, There were already swarms already again. Whereas with Novacrid, as I explained before, we had the possibility that our fungus contaminate the locusts that we have not even touched, because the locusts touch each other. So that in itself led to death of a greater part of the population, slower than Malathion, but more effective because there was no increase in the population. And then in Tanzania with the red locust, the most beautiful of these locusts, but one of the most dangerous, we saw that 88%, there was 88% death and a lot of mycosis, which is good because that means that the locusts infect each other with the Novacrid fungus. Now, to explain a bit the manufacturing process, well, the process is manufactured. It takes a while because we have to go through several steps, two types of fermentation. There's a liquid state fermentation first, and then a solid state fermentation. Each fermentation is carried out several times to achieve a Metarhizium macridium concentration as high as possible. So once liquid fermentation occurs, it is sterilized. It is separated from the liquid. It is put in a substrate, a solid substrate, and then we begin the solid state fermentation process. Once these two fermentation processes end, when we end up with a very high concentration of fungi, then we will go down a very delicate process, which is separating the fungi achieved and the growth substrate. There we isolate the fungi, and the fungi we will dry out completely and pack them in a vacuum. So our product is 99% Metarhizium macridium, totally dried, and therefore it has a long shelf life and can adequately bears heat stress and things like that very well. So this is perfect for the field. And allow me to highlight that with Elephant Vert, we have the only plant dedicated specifically to Metarhizium macridium in the world. We are the only ones that have bet on that for biological control of locust. These are some photographs of our production site, quite large in fact. We can manufacture 1 ton per month. It takes a long time to manufacture. I told you, remember, this is sort of a greenish, dark greenish powder. And our objective there is to have the plant operating continuously to avoid downtime and have the best possible quality. As I was saying before, this is totally harmless to the local fauna. Many trials have been run, and there has been no toxicity to birds, fauna, fish, and above all, very important, no toxicity to bees and other insects. Bees, we saw when after spraying several times that when they spray chemicals, the bee population drops significantly. So, and when we apply Novacryl, the bee population continues the same. We have proven this. We have tried to infect bees with Metarhizium macridium, and it is totally harmless. It does nothing to bees, and that is very important. And I believe that evermore we will have to work with this type of solution because bees for agriculture are mandatory. So here you have the ingredients. Notice that it is over 99% of the product is metarhizium acridum. It is a solution, and here we can see a solution, a comparison with other chemical products used to fight against locust, chlorpyrifos, deltamethrin, etc., etc. And we see that, yes, many are effective, but the problem of this efficacy is that, first of all, it is not selective. So it kills all types of insects that get sprayed or wherever the product is sprayed. There is no persistence as metarhizium acridum. That no chemical product has that same level of persistence. And while locust can create resistance to the other active materials, it cannot create resistance to fungi. So we do not have that risk of creating resistance. We have always used it, and the locust has come out very well. We can see the carcinogens, the toxicity for environment, for human beings, and here we have come up with a solution that allows to not to fear harming local fauna at the time of spraying or local populations. And so now our objective is with Novacryl. Well, this is a product that is very effective in the event of crises, but could even be more effective if it is done through preventive control. And this is what Jan was talking about before, talking about the possibility to see what weather will be like in X time to determine whether there will be possibility for rapid breeding of locust or not. So that preventive control is a key element here. It is important to know the areas where the locust feeds or where they breed, monitor very closely, and try to fight against the locust before it turns or becomes gregarious. The objective is to maintain locust in solitary as any type of grasshopper, so that it does not form swarms and not become a greater problem for local populations or agriculture or anything else. So with preventive control and with an ecological, biological product in sensitive areas, in the event the weather conditions are suitable for rapid reproduction, well, with that we can reduce the risk, reduce the destruction of crops, reduce the economic expenses, because preventive control is much less expensive than having to act in the event of a crisis. And we can avoid having to spray chemical products that may harm the environment and the ecosystem. So this is a product that is inexpensive as any product in the end. Well, if it is used for preventive control, it is very, very efficient. We saw a high mortality rate, very good persistence, good selectivity, and it is a safe product that does not harm the environment. Now, next steps or further development, we need to talk about the future. What we seek with Elephant Vert is to create synergies between the state authorities or among state authorities, associations, intergovernmental organizations, etc., and ourselves for preventive control purposes, and create awareness among the authorities in the sense that to apply chemical products in the forest to address locust problems is not a solution because we're killing many other insects. And we need to promote that risk of applying chemical products. We need to promote the importance of preventive control and also, in this case, the use of the ULV technology, which allows to apply the product with using very little water. And for us, as manufacturers, we can better anticipate all product requests to have a production calendar or timetable that is reasonable and that will allow us to make the best quality product and deliver our products on time. So an example I would like to share with you is the case of the desert locust, a type of locust that is very dangerous, the most famous. These are the huge swarms we can see in so many videos from Africa. And back in 2020, 2021, as Jan was showing before, there was a very big outbreak in Africa. So there, we played a key role in this because we partnered, we created the synergy I was mentioning before with the UNFAO, and we were able, first of all, to increase the use of biopesticides because before, to control locust swarms, when there was no locust outbreak, they were only using chemical pesticides. And we ensured that during that tremendous crisis, the worst locust crisis, we got them to use up to 10% of biopesticide, our product basically, our Metarhizium acridum, going from 0 to 10%. I know that may sound very little, but that is a tremendous increase anyway. And we have seen very good results. Thanks to that synergy with the FAO, well, the FAO was doing very good preventive control and has been able to manage it in due time. And they have asked us for the product with sufficient lead time. And we manufactured the best quality product. And it has been very effective. This is precisely what we seek to do anywhere in the world. So what happened in Argentina, the problems in Argentina, well, the situation could have been better with this type of partnership or synergy and by applying biopesticides to avoid killing such a large bee population, for example. So this is basically it. We, as Elephant Vert, seek to work in a less cyclical manner, instead in a much more regular manner to deliver the product in time at the best quality. And for global agriculture and for food security, we know that preventive control is much more efficient than all controlled tools. And we could avoid many locust crises, and we will not face these problems of thousands of hectares gobbled up by locust. Well, basically, this is my presentation. And let us, I guess, move to questions. Thank you, Bastien. Excellent presentation, very thorough. Just as in the case of John, on the screen you can find the contact information if you want to write directly to him. And if you want to, you can also do it through the GICSV group that also addresses this issue throughout the continent. To advance with the questions, we have several. And if you agree, I will try to organize these from production to spray. Let's put it that way, to go very much in order. To start with, then, there is a question that I believe Now, you mentioned during the presentation, but let me repeat anyway. How much time does it take to produce it? How long will it take you to produce a lot, for example? Okay, well, okay, let me go back to that. Let me go back. Okay, here. We always recommend 3 months lead time. To have enough time to manufacture the product with enough time, 3 months, therefore, is what we recommend. In the case of crises, well, we will start operating full-time, but there are limits. The advisable time frame would be 3 months. As I said before, there are different types of fermentation processes, so that takes time. So minimum, the product would not be ready before a month and some. Okay, another question. Is there any laboratory, any that can run trials of this fungus on other species? Thinking specifically of species in the Americas.
¿Qué tipo de especie? ¿Otro tipo de insecto?
Oh, other types of insects, Diptera?
De langostas.
Oh, locust, okay. Well, let me see. We have tested with different locust species. I do not have the complete list here on my slides, but very likely the Cerca cancellata, Cerca cancellata, we have had very good results with this. And we do not have a laboratory as such in Latin America, but we can always send the product there and run trials with any laboratory in the area. Thank you. Okay, now spraying. Is this Metarhizium acridium strain that you use, is there risk of displacing other native strains present in each of the regions? No, there is no risk, because as I was saying, as maximum in the event of vegetation and a lot of moisture in the area, this is maximum 6 weeks. So after 6 weeks, we have never seen that Metarhizium acridium remain there. The microbial fauna, the normal microbial fauna in the area will prevail again, and Metarhizium acridium will disappear. When we talk about persistence, we say that we have more persistence because by having a significant amount of locust, Metarhizium can breed, grow, etc. But when the locust population drops, then the fungus disappears because it basically feeds from locust. Okay. During the presentation, you made a comparison between a biological product and the chemical products. You mentioned resistance particularly, and there's a question here on this specifically. And the question is whether there is evidence of resistance to products. Do you have any reference, and why, if not, there is no risk of resistance in the future? Well, Eli is here. He is a much better expert in resistance. Eli, are you here?
Hi. Can you hear me?
Sí.
Yes. Okay. Yes. No, about our chemicals, we have some references that we can send eventually after differentiation. And with fungi, we have no resistance observed by now, and we have no scientific articles speaking about virus resistance about fungi. But actually, we could also imagine it for fungi. It's just that being a new product, there are no current resistance to fungi for the locusts.
Eso.
Okay.
So the fact of alternating some different products to fight locusts enables to have less resistance because of the use of different substances.
Ujú.
Ok. Bien. Entendido. Gracias.
Thank you.
Bien. Continuando en un
Continue with the same topic
de aplicación.
in terms of applications.
Hay una pregunta
There was a question about
muy técnica también.
very technical, as it was presented to Jan, if it's you recommend the application of this product
Se encuentran langostas en estado solitario.
when the locust is in solitary stage. Yes, we recommend that application because at the end it's a preventive application, but not when it is in solitary stage in areas with low probability of reproduction and when there is no climatic event, favorable weather events. We recommend a preventive control when there is possible risk of quick reproduction of the locust when we see there is going to be high temperatures or with moisture and rain, which is a favorable time for locust reproduction. And in certain area, we see a high concentration of locusts in solitary stage. That's when we recommend the application. The objective is not to wait until they move to the gregarious stage, but do the treatment before. And when there is these conditions every year, once or twice a year, applied a preventive treatment to avoid any risk of swarm creation. I think it's very interesting and it's related to Jan's presentation. We have to foresee the future or the weather is important to see if it's necessary to do or not the application. We move forward with some questions. We have another one from if there is any nymphal stage where you have had higher response or it's more general. It is more general because the fungi attacks any stage of the locust since the eggs to the nymphal stage. The fungi always can attack, infest the locust. Here, another question. Do you have any measure the efficiency, the nymphal or adult stage? Can you see any different? Is there higher mortality in nymphal or adult stages, or is it similar? Bastien, is something similar? I think, Eli, we haven't seen any difference in between the mortality in adults and nymphal stage. Is that right?
Yes, it's quite similar.
Ok. Siguiendo con la aplicación.
We follow the application. Amel was asking some questions. Can you talk about volume usage? And you also mentioned a surfactant. What is the objective to use that product with the ULV, not only with water? The objective, here we have it. In ultra low volume, the objective is to mix it with oil, mineral oil, or corn oil. There are several oils that you can use, and obviously the objective is first, when there is lack of water, to be able to apply the treatment with aerial treatment or drones or planes. And surface application is important with low liquid applications. That's the objective of the ULV. And then the surfactant is the same, is to reduce the amount of water. There are many types of surfactant that can be used, and it's to reduce instead of to apply 50 liters of water as a treatment. You can use less water, but be as efficient and to cover foliar spaces with more water volume. I don't know if there's another question, Ellie?
Just to say that the surfactant also help the dispersion of the fungi in the water.
Ujú.
And okay.
Ok, bien. Gracias. Referido
Thank you, Hector. In terms of a control, ULV control, there's a question about from Amel. He's asking if, in terms of the equipment, the ULV equipment, have you used a specific one? We understand there is large equipment with planes. Have the result been the same with all of them? Ellie, would you like to answer that?
Yeah, we usually work with the Micron technology. So it's an English manufacturer that produces different type of equipments, backpack, trucks, and planes.
Gracias,
So
Eli.
it's called
Ian?
Micron technology.
Ok. ¿Han tenido experiencia
Have you had any experience with applying this product with drones?
Eli,
No.
¿hemos hecho drones? No, no.
By now, no. We have some contacts that want to try it, but we didn't do it.
Ok. Aquí hay otra pregunta.
There's
sobre
another question on metarhizium.
y la pregunta es,
The question is if this strain, acridium, is adapted to higher temperatures. You said you have tested some strains and there have been some issues with high temperatures. This strain, yes, works well between 20 and 35 degrees. When it reaches higher temperatures, it doesn't work that well. The bacteria, the fungi, it doesn't die if we go beyond 35 degree. But if it's high temperature during a lot of time, it's going to affect the fungi. However, if the temperature remains between 20 and 35 degree, the fungi is going to work very well. Thank you. Hector, it's going to be important at the time of application. Then you have to look for the lower temperature. Bastien, yes, we recommend apply earlier in the morning or later in the afternoon. Hector? Perfect. I'm trying to see if there's any other question for both of you. Very good. Just 1 second, please. I don't think we have any other questions. There is a Bastien contact as well as Mr. Dutton. They have been very interesting. We hope to be able to be working together with both topics, which are going to be very important for us as a continent. In order to continue to get some conclusions from this event, I'm going to let now Mr. Zagaglia from CUSAB in South America to speak. and they have various locust species. We were going to ask him, after listening to the presentation, maybe he can make some comments that are important. Gustavo? Good morning or good afternoon. It depends on what part of the world you are. Talking about what we said at the beginning from this working group, Locust working group in GICSV, we could say some lacks early warning systems or for alternative for biological control. In this framework is where GICSV is trying to offer this webinar so that we can to reinforce capabilities in the region to manage locusts. Now, in terms of specific topics and forecasts, we have been working with short-term forecasts, general, and those tools that Jan presented include these tools, these models will allow us to, in one hand, to have early alerts, the growers, producers, in case of an emergency, or preventive actions. And us, that we are the national regional organizations, it also provides us tools to more efficiently use our resources, to guide our human and material resources to areas which are prone to this, and we can apply preventive management and avoid possibly emerge. Now, from the point of view of biocontrol, I'm reading a little bit here that I took note. We know biocontrol and other continents are using it largely. Here we are a little bit more restricted. Some countries use it, but not massive way. We have an excellent alternative from the ecological and in terms of the environment, the alternative that it was mentioned, and the advantage on chemical products. We mentioned the incremental effect, the capacity to resistance on locust, in terms in comparison to chemical products. That's from the ecological point of view. Now, take into account the low probability of active principle for chemical products. Chemical control, biological control for preventive management, it would be to avoid excessive use chemical products. I thank you. A very complete presentation, Jan, Bastian. We want to thank GICSV for organizing this webinar. Hector, thank you, Gustavo. As mentioned, Gustavo, he's in South America. We're going to ask Amel, but he works and he lives in Trinidad and Tobago, and he represents the Caribbean area in our group. Maybe he can provide some conclusion reflections regarding this webinar. Amel?
Yes, thank you. Just to re-emphasize what Gustavo said, the GICSV working group, through surveys, recognize that there are limited options for controlling locusts with synthetic insecticide. But also recognize that synthetic insecticides is currently the main method of control, particularly in emergency situations. But based on recommendations from FAO, the GICSV working group on Orthoptera pests promotes a preventative locust control strategy, considering the impact on human health and the environment, and working towards the application of biopesticides. So this seminar on biocontrol and climate forecast focused on locusts is part of the working group program for strengthening cooperation between the America regions with other international organizations and specialists in the field for the improvement of preventative management systems and emergency response. So by sharing of experiences and knowledge, we can generate positive results to transform the current situation. Within the framework of the 2020 International Year of Plant Health, a series of seminars were organized to address the locust problem and promote innovative solutions for its mitigation in Latin America and the Caribbean through this working group, and with the participation of FAO and ICA. So this seminar is a continuation of this effort to address the program objectives of the working group. So I want to take this opportunity on behalf of the GICSV working group and of CAPSA, which I represent, to thank all the participants for attending and contributing through questions and discussions, which we all learned from, and sharing the concerns and the experiences. I also wish to thank all the presenters for imparting their knowledge and the information and contributing to this relevant seminar on biocontrol and climate forecast for locusts. To Dr. Jan Dutton, CEO of the company, Weather Limited, ClimeBiz World Climate Service, on the special topic of long-range forecasting and the importance of providing early warning systems as it is associated with locust infestations. And to Mr. Bastian Glare, Technical Sales Manager, for his topic on the use of Metarhizium acridum. Very interesting, and that's by the number of questions. Our country in the Caribbean region, Trinidad, which is affected by locust species, grasshopper species, we want to work towards implementing a biological control strategy. So definitely we will be looking for more information as we move in this direction to better understand the strategy and how to implement the use of the biocontrol agent. To Dr. Stephanie Bloom, the GICSV coordinator, and Ms. Ana Marisa Cordero, Agricultural Health and Food Safety Program Manager, AICA, for their contribution, and to Mr. Hector Medina from Senasa, Argentina, as the coordinator and chair of the GICSV working group and lead for directing the GICSV locust group. Thanks. And to moderator, Dr. Mario Put, a technical expert in the area of locusts, as well as with Hector. And to all the members of the GICSV working group who contributed in making this event possible, including our technical secretary, Ms. Maria Lourdes Fonalaras of AICA, and Ms. Delca Marine Martine of NAPO for additional responsibility as the interpreter. Thank you very much.
Gracias, Amel. Muchas gracias por tus palabras y
for your words. And on behalf of the group, I want to thank to mention Mario Pod. I also want to thank who also help organizing this event. Before going further, the information on this group can be found on the GICSV Working Group website. We are going to be sharing the contacts of the presenters in case somebody will like them, and we'll have the information of the events. Nothing else from our behalf. Thank you very much to Maria Lourdes Fonalleres, and you have the word now to close this webinar. Lourdes, thank you, Hector. You said everything that I had to say, but I wanted to highlight the objective of today's webinar because it is a strategic focus and very current to control a very concerning past. What we analyzed today in terms of prevention and to control to protect the environment is very precise nowadays, and I think it provides tools, very interesting tools for all the expert group members. Then we multiply. We integrate the region of the Americas and the Caribbean. And I just want to highlight this. And this event is very important. You already went ahead with some thankfuls. I also wanted to reiterate my thanks to Elephant Bird and World Climate Service. Your effort, Mr. Bastien and Mr. Elien. I also want to thank especially to the interpreters, Cynthia and Nedelka, for their effort. And lastly, not last, to thank the people who are behind stage and which make this possible. And this is Adriana and Ricardo Valle from AICA, Juanita Picado, who's provided all the support and organization of the event, as well as Jose Arrua and Maribel Hurtado, who together with Stephanie have supported this event. Thank you. I think I was very successful, and I wish you a good afternoon, evening, or whatever time you are. Thank you very much.
Muchas gracias a todos.
Bye bye.
Muchas gracias.
Thank you. Goodbye.
Thank you.
Recording stopped.
Recording has stopped.